Let's talk about solving rational inequalities. So let's solve 5 over x minus 1 is less than or equal to 4 over x plus 2. It's a rational inequality because I have rational functions involved, and it's an inequality because of the inequality symbol in there. Similar thought to what we use with polynomial inequalities. We're going to shuffle everything to one side so that we're comparing it to 0. You can go either side. I'm going to go left. So we'll have 5 over x minus 1 minus 4 over x plus 2 is less than or equal to 0. And I'm going to turn the left side into one fraction. So my common denominator is going to be x minus 1 over x plus 2, which means the 5 was missing in x plus 2, and the minus 4 was missing in x minus 1. So let's simplify this up just a little bit. So I'll end up with 5x plus 10 minus 4x plus 4 over x minus 1 times x plus 2 is less than or equal to 0, which means I'll have 5x minus 4x is a 1x, and a 10 plus 4 is a 14. The numerator and the denominator is still x minus 1 times x plus 2, still less than or equal to 0. So I'm going to think of this left side as the function that I'm working with. So let's think of f of x is equal to x plus 14 over x minus 1 times x plus 2. Now, there are two places where a rational function could change signs from positive to negative or negative to positive. Either it could do it by crossing the x-axis. That happens when it's actually equal to 0, which means that is when x plus 14 is equal to 0. So that happens at x is equal to negative 14. That's a 0. It could cross the axis there and change sign. Or it could do it as you cross a vertical asymptote. As we've seen, you could be down on the left side of a vertical asymptote and up on the right side of a vertical asymptote. And those vertical asymptotes happen when the denominator is equal to 0 and the numerator is not. So I'll start by saying the denominator equal to 0. That happens at 1 and negative 2. And the numerator is not 0 at either of those. So these are both vertical asymptotes. Okay. And it could happen even if they weren't vertical asymptotes that you could switch the signs on it. So essentially, I'm going to build my number line for the places to look for where this could change signs as the zeros of the numerator and the zeros of the denominator. So here's negative 14, there's negative 2, and 1. All right, so now I just need to figure out the sign in these places. So I'm going to pick my favorite number to the left of negative 14. I'll go with negative 20. And again, all I care about is the sign. So I'm going to plug this into f of x and look at since I have it already all factored out, I'm going to look at the factors of it. So if you plug in negative 20 in for x, negative 20 plus 14 is negative. And then I have a negative 20 minus 1, that's negative, and a negative 20 plus 2, that's negative. So overall, I'm going to be negative in there. Favorite number between negative 14 and negative 2, I'll go with negative 10. Plug it into the function, a negative 10 plus 14, that's positive. A negative 10 minus 1, negative. A negative 10 plus 2, that's still negative. So overall, since I have two negatives and one positive, it's going to be positive in here. Favorite number between negative 2 and 1 is 0. X 0 plus 14, positive. 0 minus 1, negative. 0 plus 2, positive. So overall, I'm going to be negative in here. Okay, favorite number to the right of 1, I'll go 5. 5 plus 14, positive. 5 minus 1, positive. 5 plus 2, positive. So overall, I'm positive over here. Okay, so that's the setup. And I had turned this into, I wanted when f of x was less than or equal to 0. So I am going with f of x is less than or equal to 0 because this inequality that I've boxed is equivalent to solving the original. I just rewrote it so it was in a way that I could deal with it a little bit better. Okay, so I want essentially the negatives of these. So f of x is less than or equal to 0. My solution is from, looks like over the left here, negative infinity up to negative 14. Now, negative 14 makes the numerator 0, so that's okay. I can include that. Union, and then let's see, the next negatives are between negative 2 and 1. The problem with negative 2 is if I plug in negative 2 into the function, I get a 0 in the denominator. So negative 2 isn't in the domain of that function. So this is going to be an open parentheses. I do not get to include it because it's not in the domain of the function, even though I wanted a less than or equal to 0. Similar reasoning for 1. 1 is not in the domain of that function. So even though this is f of x is less than or equal to, I don't get to include it because it's not in the domain of the function. So that's the solution for my rational inequality, is that we have 5 over x minus 1 is less than or equal to 4 over x plus 2 for negative infinity to negative 14 inclusive, union, exclusive, negative 2 to 1 also exclusive.